All right. So today we're going to start our new unit on learning about three-dimensional figures. Our success criteria for today is we can solve problems involving composite figures and net. And this is going to help us kind of transition from area to surface area because we've talked about how to find the area of basic figures. Well, we're going to talk about how we can use nets to find the area of three-dimensional figures and not just two-dimensional figures. What we'll be doing is this week I have already posted our must do that goes that where I have a video of this actual lesson, and then I will have our independent practice as well as the should do's posted for you on Google Classroom. Today during class, we will work on our introduction to composite figures and nets. That'll be notes. We'll do some partner stations tomorrow with figures and nets. We'll have our composite figures and nets puzzles. And then on Thursday, I'll make sure that you have plenty of time to finish up that independent practice, as well as the IXLs and the Aspire to Dos. I will be posting on Friday. I'll have some of you guys will be taking those Unit 7 reviews and retakes for different sections that you didn't necessarily do as well on. And then I'll also have the Aspire to Do posted for you guys to work on for those of you who finish those retakes. But right now, what we're going to do is we're going to go ahead and talk about the area of composite figures. So, composite figures are just figures made of more than one shape. And what I want you to do right now is go ahead and tell me what shapes make up the composite figures below. All right. What you should have posted is here. If we look at this first shape, we've got one, two, three rectangles that make up that figure below. In the second figure, we've got a rectangle and a triangle that make up the figure below. And here we've got where we could combine these two sides and it'd be one circle and a rectangle. And finally, we've got a triangle and another rectangle that make up this figure below. And we can use these because we have the measurements. We could use these to find the area of each figure and then combine them, which is something that we're going to do right now. So when we're looking for the area of composite figures, there's three steps to take. Number one, split the shape into parallelograms, triangles, or circles, or whatever figure they are. Then you find the area of each smaller shape, and then you add or subtract the values of each shape to find the total area. So what I did in my teacher model here is I went through, and I'm going to shrink this a little bit, and I found that I had two rectangles. So the area of one, this is my area, this is my first shape right here, is 2 by 1, 2, 3, 4, 5, 6, 7 blocks. So I said area one of the first figure is 2 by 7 or 14. My second figure is 3 by 4 or 12. So then I add my area 12 plus 14, and the total area of this figure is 26. In this one, I have got a triangle and I've got a rectangle. So my triangle is, remember our formula is half the base times the height. So my base is 1, 2, 3, 4, 5, 6 squares. My height is 1, 2, 3. So I do half of 6 times 3 and I get 9. My second area is 1, 2, 3, 4, 5, 6 squares by 1, 2, 3, 4, 5 squares. So I do 6 times 5 and I get 30. When I add the area of those two figures together, I get 39. Go ahead and find the area of these three figures on your own. Okay, you should have had, for the first one, you should have had 54 because we had 6 by 4 with a rectangle. And then we had 6 by 5, sorry, half of 6 by 5, and I'll fix this right now. Half of 6 by 5, so I did this wrong. Make this a little better for the people in class. So half of 6 by 5 was 30, 30 is 15. So we end up with 24 plus 15, which ends up equaling 39. So I fixed that one because I messed up, which happens. I forgot to put that half in there. The next total area we have 4 by 6. So I had two different different rectangles. I actually separated into a big rectangle right here. So I had 4 by 6 here, and then I had 2 by 2 here in this little rectangle. So I got 28. Here I split it into three different sections. And the sections that I split it into, I've got a 2 by 5 here because I did my cutoff here. So I did 2 by 5. I did 1 by 5, which is this section right here. And then here I had 4 by 8. So I got a total area of 47. You can also, sometimes you'll have shapes that are the same size, and we're going to get into these. These are things called nets. And with a net, you'll have different things that are the same size. So I have one, two, three rectangle, three, four rectangles that are the same size. So I'm saying 4 times the area of one of these figures. So the area of one of these figures is 3 by 7 or 84, or 3 by 7, which is 21, but I've got 4 of them. So it ends up being 84. I've also got 2 squares. So I'm saying 2 squares times 3 because 3 by 3 is their area. So I end up with 9 as their area. And since there's 2 of them, 18. So when I add them together, I get 102. Find the total area of the other 2 figures. Okay, when you find the area of the other 2 figures, so here we've got 2 of these rectangles that are 4 by 5. So 4 by 5 is 22 of them equal 40. We have got one big rectangle in the middle that's 6 by 5, and that's 30. And we've got 2 triangles. So 2 times ½ times 6 times 3. You notice I did it right this time. Ends up being 18 because one figure is 9. So 2 of them will be 18. And when I add those together, I get 88. For the other one, I have got 1, 2, 3, 4 rectangles that are the same size here, and those are 3 by 4. So you can see I've got that here. I've got 2 rectangles that are 4 by 4, so they're actually squares. So 4 times 4 is 16 times 2 is 32, and I end up adding 48 plus 32 to get 80. And those are things, those nets that I did that, and we were able to find what is called the surface area. So looking at our 3D figures and nets, three-dimensional figures are made up of the following parts. They've got a face, which is the sides of the figure, including the bases. You've got a base, which is a special name used to name the shape. You've got an edge, which is the side that joins the 2 faces, and you've got a vertex or the corner where the edges meet. And I'm not going to have you answer the question on this, but we can actually use that terminology to label the various parts of the rectangular prism and the rectangular pyramid below. So this is a rectangular prism. And the reason we call it a rectangular prism is we name everything by its base. So if its base is a rectangle, that's what it's going to be. And then we name it by its faces. So the base is a rectangle, the faces are rectangle. So that makes it a rectangular prism. Um, the vertex is the corner. We've got our face, which is a rectangle. So again, our base is a rectangle, our face is a rectangle. So it's a rectangular prism. Okay. Here, my base is a rectangle, but my face is a triangle. So this is a rectangular pyramid because a pyramid is going to be built of triangles. A prism is built of rectangles. So a net is a two-dimensional composite figure. Okay, when folded, a net creates three-dimensional object. And a prism is a solid figure with 2 parallel bases that are separated by the height of the figure. The bases are congruent. And here's what I think about. Prism has two parallel bases, but its faces are always going to be rectangles or squares because a square is a type of rectangle. So go ahead and name the type of prisms for these 3 shapes below. Okay, so this one you can see that its bases are squares and its faces are squares. We'll call this a cube, but it's also could be called a rectangular prism because, as I said, squares are rectangles. In this one, my bases are rectangles, my faces are rectangles, so we've got another rectangular prism. In this one, my bases are triangles, so it's going to be a triangular prism because I have the triangle bases and I have 3 rectangular faces. That's what makes it a prism. A pyramid, on the other hand, is a solid figure with one base and triangular faces. The height of a pyramid forms a right angle with the base. Pyramids are named by their base. So go ahead and name the type of pyramids here. So here you have a triangular pyramid because the base is a triangle and the faces are triangles. Here you have a square pyramid because this is the same on all sides. And of course, it's a pyramid because its faces are triangles. And finally, we've got a rectangular pyramid because I've got a rectangle and four triangles. So that is going to be a rectangular pyramid. What I want you to do now is go ahead. I'm not going to I'll have you label this on your paper, but we're going to go ahead and label the sides, and then I'm going to have you find the area of this. So here, this one goes with it. It has two triangles as faces, so they're parallel and rectangular faces. So this is a triangular prism, which matches up with this. So we are saying that this triangle here is 6.5 by 6 feet, and our rectangular faces are 5 by 15. You can see the measurements I have here because when we fold it out, we say that this one matches the cube. So we're saying we've got 7 by 7 for each one of these faces. So I would do 7 times 1, 2, 3, 4, 5, 6. Here I have got a rectangular prism. And so you can see that I've got the measurements here are 6 feet for each one of the bases. Okay. And I've got four different measurements because I've got 6 feet by 10 feet here. I've got 6 feet by 10 feet here. Okay. This is going to be 2 feet by 10 feet. This is 2 feet by 10 feet. And this is going to be 6 feet by 2 feet. And so I could find the measurement of all of these and find the area. The last one is a rectangular prism. And so we can see that that matches up there. What I'm going to have you do is go ahead and find the area of these prisms, of these shapes. All right. So if you're finding the area of this figure, what you're going to do is we've got 1, 2, 3 rectangles that are the same shape, and those are 5 by 15. So I had 3 times 5 times 15. And then I'm adding the area of the two triangles, which are the same size. So I've got 2 times half times 6 times 6.5, and I got 264. For my next shape, I have cubes. So I have 6 things that are the same size. So I said 6 times the area of one of the figures, 7 by 7. When I do that, I've got 6 times 7, and I get 294. For my last one, I have 3 different types of shapes. I've got the rectangle right here, which I have 2 of. Those are 10 by 6. I have the rectangle that is the 2 longer rectangles, which are these 2 rectangles here. So 6 feet by 2 feet. I've also got my 2 feet by 10 feet right here. So I've got 2 of these longer rectangles here, and I get a total of 184. In my last one, I've got one rectangle that's 12 by 8 feet. I've got 2 triangles that are the same. Those are 9 feet by 8 feet. So 2 times half times 9 by 8. I've got 2 more triangles that are the same. They are 8 feet by 12 feet. So with I end up with I said 8 by 10, and it should have been 8 by 12. So let me fix that. Because that 10 does not matter where it's at. And I was trying to do too many things at once. So here, I'm going to go ahead and change that. And so the area for that, I think I have messed up horribly. So we have 12 times 8 plus, close parentheses, plus 2 times 1/2 times 8 times 12 plus 2 times 1/2 times 9 times 8. And we get 264. So I had messed that one up because I put a 10 instead of a 12. but we got it fixed. Okay. What I'm going to have you do now is go ahead. It is not due until Friday, but go ahead and start working on the independent practice and then work on the IXL that goes with this lesson.